Good afternoon, ladies and gentlemen, and thank you so much for joining us today in our webinar. My name is Titus Quech from Jinko Solar Technical Service Department, Middle East and Africa. Today we're going to have a discussion on advanced PV technologies that have played a key role in lowering LCOE in 2020. I'm really hoping that you're going to learn a lot from the session, and if you do have any queries, please do ask at the end of the session. To start with, allow me to briefly introduce and also give some key facts about Jinko Solar. Jinko Solar is a Chinese module manufacturer established in the year 2006. And also we are leading globally in terms of shipments, having shipped up to 25 gigawatts of modules as at Q4 of 2019. We currently command a global market share of 12.8%. and also own a cell efficiency record of 24.58. We've recently been ranked as the most bankable PV manufacturer for the 5-year period between 2015 and to 2020, that is by PV Tech. We do have 7 global factories for wafer, cell, and also module manufacturing. In our product portfolio, we currently have 3 series of products, that is Cheetah, Swan, Tiger, and also Tiger Pro, with a maximum power class of 585 watt peak. Cheetah and Swan were launched in 2018 and 2019 respectively, whereas Tiger and Tiger Pro were launched in 2020. Now, back to our main topic of the day, that's levelized cost of energy, which I can define as the cost of power produced over a period of time. It's a key parameter that's used to compare different technologies for energy generation. And it also acts as an indicator of the competitiveness of the energy generation technology. This is because it would be difficult to compare different technologies because they have different lifespans. So it would be difficult to compare them using CapEx or the initial investment. For renewable energy, also solar PV, the LCOE has greatly reduced for the past few years and even becoming more competitive and reliable than use of traditional fossil fuels. LCOE puts consideration both commercial and technological aspects. Commercially, the cost of the PV module, inverter, BOS, rather balance of system, installation, land, and also R&M cost plays a key role in determining the LCOE. Also of importance is the yield generation. Like the case of solar PV, the yield, energy yield is actually dictated by a number of factors, including the efficiency of the module, the degradation of the module, the warranties, the temperature coefficient, the power tolerance, the reliability of the module, among other factors. The most recent record low LCOE we've seen was for solar PV was in the Al Dhafra project in Abu Dhabi, announced in April 2020, with a record 1.35 US cents per kilowatt hours. Now to dive into the trends in LCOE, as you can see from the graphs that is from Bloomberg, there's a deep dive in LCOE from the past years, especially for renewable energies like PV and wind. And ideally, Bloomberg estimates that currently for 2020, solar PV LCOE has fallen to $50 per megawatt hours. So if you compare it to the second half of 2019, that's a 4% reduction in the LCOE. And also, it also tallies with reports from other institutions now proving that solar PV is among the cheapest sources of energies in a number of countries, regions like Australia, China, some part of Middle East and Africa, and also some part of Southern America. Now, for solar PV, we've undergone a number of technological changes, rather advances in the last few years, especially since the introduction of the high efficiency monocrystalline cells. This particularly enabled the production of high power and also high efficiency solar PV modules. So the high power density, or rather efficiency, plays a key role in reducing the levelized cost of energy from the solar PV plants. I'm briefly going to highlight some key technologies that have been recently introduced in the market and have played a key role in this. To start with, I would like to indulge into the tiling ribbon technology. This is a new technology that is commercially available now, and it involves the elimination of gaps, that is the traditional gaps, that is 1 to 2 millimeters between the solar cells in the PV module. So this overlapping of the cells employs use of a special round ribbon to connect the cells. And from the diagrams below, we can see how the overlapping is done, comparing the conventional to the new TR-based modules. And again, also the ribbon used for the overlapping of cells is squeezed at the center to ensure maximum reliability and also reduce chances of micro cracks. What is also key to note is at the overlap region, we're using special encapsulant, that is EVA or POE, at the overlap area to ensure the reliability, and also to ensure that the overlap area, or rather the cells, can absorb stress and this is done at high temperatures. Tiling ribbon technology alone has resulted in increasing efficiency of the modules by more than 0.4%. Now, to briefly look into multi-bus bar, I would say multi-bus bar is now becoming a new standard in the industry, not only from Jinko Solar, but also most of our computers are now going that way. And we are slowly phasing out the traditional 5-bus bar modules to pave way for 9-bus bar and 10-bus bar modules. Multi-bus bar reduces the current path, by more than 50%, and minimizing the internal losses in the cells. So it still also involves the use of round ribbons, or rather wires, instead of the conventional rectangular ribbons. The round ribbon has smaller cross-sectional area, which implies that there's an increase in the ribbon resistance according to this particular formula. And also looking into the formula below on how to calculate the relationship between PR and the relation between PR and ribbon resistance, you can see there's a direct relationship. So that means that an increase in ribbon resistance will ideally result into an increase in the performance ratio as well. Also, comparing now the round ribbon and also the rectangular ribbon used before, is that the round ribbon essentially improve the optical features of the module by reflecting more light into the solar cells. So ideally, this will improve the IM values, and you can see this from the pan file reports that can always be shared to you. And now is what we can say is Jinko modules, ideally with 9-bus bar and also 10-bus bar, are proven to generate up to more than 1.5% more power compared to conventional 5-bus bar modules. Now, allow me to now look into the half-cell technology, which is not really a new technology, but a rather trend in the industry at the moment, and we also expect that beginning next year, all our modules will be half-cell technology. The technology involves carrying the cells into 2 equal halves to reduce the internal losses in the solar cells. This is essentially will result into low working temperatures and also reduce chances of hotspots in the modules. And just to mention is Jinko's modules with the Afsan technology have the lowest and also the best industry temperature coefficient, that is of minus 0.35% per degree Celsius, hence increasing the yield at regions with high temperatures. So also is thing that I want to also briefly talk about is on bifacial modules, especially with transparent backsheets. And bifacial modules with dual glass have been existing in the market for the past few years. And ideally, bifacial modules involve generation from the front and the rear side of the module. So in 2019, Jinko in partnership with DuPont came up with an innovative solution of using transparent backsheet for bifacial modules. So the transparent backsheet compared to glass modules, have one is better heat dissipation compared to glass modules, and hence resulting to low module temperatures. The other principal advantage of the Tedlar-based transparent backsheet is the self-cleaning feature because of the stain resistance. This will result into reduced soiling at the rear side of the modules, and hence reduces the frequency of cleaning, of the module on the rear side. So now is also the other key thing about the transparent backsheet is it results to modules of lighter weight compared to glass module, and it makes a lot of economic sense, especially when you're going to the high power modules, where we need to control the weight of the modules. So from looking into the LCOE contribution of the transparent backsheet is that it has played a key role in reducing the R&M costs, that is by up to 5% because of the self-cleaning features, and also because of the lightweight, reducing the mounting and also the labor costs. So just because by 15 and 20% respectively. Just to give a case on how we've applied all these technologies in to achieve an high power and also high efficiency module is the case of the Tiger Pro module using the high efficiency cells, and also multi-bus bar, that is now 10 bus bar, and tiling ribbon technology to have the overlap between the cells. And for the bifacial version of the module, we're using this special transparent backsheet that that's a Tedlar film to ensure the self-cleaning features and also better heat dissipation. So all this combined ideally resulted to high power and also high efficiency, and this finally low LCOE. Now to wrap up our session today, I would like to briefly give an LCOE case study for 120 megawatt project in Vietnam. In this calculation, we basing the calculation on a DCAC ratio of 1.2 and a conservative bifacial gain of 7%. And now the calculation is to compare between the 500 watt peak module and Tiger Pro monofacial and bifacial modules. And what you can see is that looking into the initial investment cost and also the labor cost, see that the Tiger Pro is achieving the lowest cost and also the lowest LCOE of around 3.86 US cents per kilowatt hours compared to 4.16 and 4.25, that is for the monofacial and the 500 plus 500 watt peak module. So in conclusion, I would say we are confident that TR-based modules with AFCAT and also transparent backsheet will result to reduce LCOE and increase IRR and return on investment of PV plants. Thank you so much, and have a good afternoon.